Okay, let's quickly talk about Apache Spark. Apache Spark is a framework, it has API for different languages, and then in this case, we are talking about PySpark, which is one of the Apache Spark's API that is communicating with applications written in Python because big data is very hard to process and manipulate, and it is very expensive in general because you need a lot of processing power, and it needs a lot of storage for keeping all of these data. First of all, because our application is written in Python language, the way that we are communicating with this application is going to be through PySpark. PySpark is basically going to be not exactly, but it is like a translator between what Python says, and it will translate it to what driver program understands. The language that it's easy for us to understand. For example, it says take, it means bring some data. That's not exactly how computer understand it. Computer doesn't understand what take means. But in our language, we understand what take means. So PySpark is taking all of these information and translate it into a language that a lower level API, when PySpark receives these instructions from the user, it will translate it to a language that the driver program would understand. And then another thing that you have to keep in mind is that Apache Spark, the way that they evaluate, they use lazy evaluation. So what that means is PySpark will receive all of these information. Like for example, it says multiply all of the data points by 2. It will give instructions like this, or it says any type of manipulation that is supposed to happen on the data points in the data set is going to be sent to the driver program. It's going to be translated into a language that driver program understands. And then driver program is not going to run these instructions. It's going to keep all of these instructions in order. Each one of those words that is very close to the human language is going to be multiple lines of code in a language that computer can understand. And when you keep going to the lower level, the lines that explain that one line of code that PySpark said is going to be more and more. Driver program uses lazy evaluation. So it means that when it is receiving all of these instruction of how to manipulate these data points, for example, divide them by 2 or any type of transformation that wants to do, it will just keep the instruction here and it won't do it until the application needs some sort of action, like it asks for something to be sent back to it. So whenever your application or PySpark is asking for something to be sent back, then driver program will send the instruction to the cluster manager. For example, your PySpark says, I want 3 rows of data. It will send it to the driver program. Driver program will send these instructions. It says, okay, so you need to divide the first 3 rows by 2, and then you need to send it back. Cluster manager have multiple worker nodes. So these worker nodes, each one of these worker nodes are a machine by itself. So that means that they have their own memory and hard drive. They can be either virtual or they can be an actual like physical machine. So this is parallel processing. So the big data that we have, the huge data set that we have, it's going to be divided in multiple partition. And each one of these worker nodes will have a partition or few partition in it, but none of them have the complete data set. Each one of them treat their own partition as a small data set. So whenever cluster manager will get this instruction from driver program, it will locate the worker node that can work on that partition of the data, and then the worker node do whatever manipulation is supposed to be done, and then whatever the result of that is going to send it directly to the driver program. So whatever worker node done and whatever the result of it was, it's going to send it to the driver program, and driver program will send it to PySpark and generally into the application. So this is how Apache Spark works. Why is this better than the normal just having all of the database in one place. All of the data, the big data, is not going to be processed by one machine, but it is going to process by multiple machines. So it is going to be faster because each machine is working on a part of it, and all together is finishing the process way faster. And then another reason is that it will load all of the data in the memory. It's going to have, you need to have lots of memory in order to be able to process this amount of data, especially because it's big data. So the processing time is going to be faster, but you need a lot of memory.